Howdy everyone, Patricia Dugan here, live from San Francisco at a Traefik online meetup. We are so happy that you are here with us, and I am so excited to be presenting a cool meetup today with Paul Curtis of Weaveworks. First, I want to let you know a little bit about what we're doing here today and what what we do with Traefik, and some cool goodies that actually launched today. So for starters, I'm the head of community, and I am super stoked to work with our large global pool of developers who are enthusiastic about building our open source project, Traefik. We also make something called Mesh, which is a simpler service mesh. And then exciting news, but today we launched a new software as a service control platform for Traefik called Pilot. And I'm going to put that blog into the chat box. And Traefik online meetups showcase ways that companies and engineers are using Traefik to solve interesting technical challenges. What we do is we deep dive into subject matter, and then these videos will go to YouTube and live forever and ever, so you can watch them at your leisure. Today, what we'll have is Paul will be speaking, and then you can answer your questions in the chat box. We will answer them at the end. There's also another thing I wanted to mention, which is that Traefik RC, Traefik had a new release today, which I will put in the chat box as well. And then I will follow up to this if you have to leave early today. I'll follow up with you later with the video. And other than that, we thank you so much for being here. And I hope you are doing super well and staying super positive and happy. And now we're going to pass the mic over to Paul Curtis, and he's going to show us everything that Weaveworks is doing with Traefik. Have fun. Thanks. And thanks, Paul.
You're welcome. Thanks. Hi, everybody. I'm Paul Curtis. I'm a principal solutions architect at Weaveworks. I'm based in New York. The company's based in London. Let me just bring up the slides, if you will. We're going to go through very quickly a set of slides. Mostly we're going to be talking about policy and policy not so much at the Kubernetes level, but definitely policy at the application level. So I need to do my 2-second intro to Weaveworks. So the important things on this slide are Weaveworks coined the term and created the idea of GitOps, which is a methodology that allows you to basically operate clusters by doing do declarations in Git, and the tooling that is required to keep that running, so it keeps your clusters running. In the demonstration, I actually use it for this, but it's not the main point. The second thing is that Weaveworks as a company has been around in the Kubernetes community, and prior to that in the Docker community for more than 5 years. And so a lot of tooling that we have written for our own use ended up in the open source. So those things like Flux, we contribute to Prometheus, EKS Control, Weave, Cortex, Scope, there's a bunch of them. So that's my pitch on the company. So let's dive right in. So what we're going to talk about today is application level policy rather than Kubernetes level policy. So I differentiate that by saying this. It's like the Kubernetes level policy are things like network policy and PSP, RBAC. Okay, those tools that are already built into Kubernetes that allow you to place static policy around very specific Kubernetes objects. What we are going to talk about, though, is we're going to talk about the next level up. So you have this great Kubernetes cluster, and you're putting applications in it, and you're using Traefik to do, for example, your API or your microservice routing. All right, how do we apply policy at that level? And that's where we're going to stay today. And I will be doing demonstrations. All of this code is available. The tool that I built to actually use this is also available. So everything's in Git, and we'll pass along the URL, and feel free to take it. I'm going to use some terminology. I just want to be very, very clear. I'm going to say microservice or application when I'm talking about the application stuff. When I'm talking about a service, I'm talking about a Kubernetes service, okay? Because sometimes people have trouble making that differentiation. I just want to be clear that's the way I'm going to talk about it. Okay, so what is application level policy? Basically, if you're building a web service, right, it's the policy and it's the user experience, basically, the way the end user accesses your service. And your microservices are what actually are running, but your application is what they see. Now, whether that's running on Kubernetes or it's running in the cloud or it's running somewhere else, it doesn't really matter. It's how the user uses what you're providing, right? And so Kubernetes has great policy work for its services, objects, deployments, network policy, pod security policy, things like that. That's great at Kubernetes. We need to move up the stack and use similar tools and techniques for application level policy. So how do we do that with Traefik? How do we use open source tooling to do it? And how do we make it non-disruptive? Right, so you want this consistent user experience that the user sees when they're using your application. So generally, there are three basic design patterns for how this works. The first one is every developer of every microservice puts policy code in their application. So whoever writes the microservice will have a function call for every endpoint in their microservice that checks policy. Now that's fine. That's not a very common pattern, and it has some drawbacks. The second one is the most common design pattern right now in Kubernetes is the idea that you put a proxy around your microservice. So your microservice stands alone and the developer doesn't have to do anything with policy, and you use a proxy. And that becomes the gateway, the way you control access to your application. And the third way, which is what we're going to demonstrate today using Traefik, is actually doing the policy at the ingress level. There's a lot of benefits. So let's just quickly go through the first one. At the application code level, the biggest stumbling block is developer time. You're asking the developer to do something that is not really a part of his microservice, okay? You're also having him put in test cases. They have to build tests around it. They have to make sure it works. Also, they have to be in contact with the people who are designing the policy architecture because they have to know what to check for, right? So this puts an extra burden on the developer. And while it is not hard to do this, there's plenty of code examples out there from various policy engines that exist. It is an additional step for the developer to have to take. So that works. It's there. I've done it in the past, so I know what it's like. And at 1 or 2 microservices, it's probably okay. At 50, maybe not so much. At 500, definitely not. Because the amount of resource wasted just in administering policy at the microservice level becomes a huge time sink. So the second one, which is the general Kubernetes pattern, is to use a proxy. And this is an okay pattern because what it does is it says the developer doesn't have to worry about it. He writes his microservice independent of everything else. Okay, I'm good with that. But it means that the person who deploys, whether that be operations or the DevOps team, has to pay attention to the fact that that proxy actually has to exist, okay, in some manner, right? So whether it's part of the ingress, usually it's not. It has its own control plane usually. A lot of people do this with service meshes, so it can be done at that level as well. but it adds a set of complexity to deployment of every single microservice and application that doesn't necessarily have to be there. The second thing is that when you get down to having now to figure out, okay, microservice 1, I got to do this mapping, microservice 2, I got to do this mapping, and I've got to do port to port, how do I build the services, et cetera, et cetera, et cetera. It's small scale, it's fine. It doesn't add a whole lot of compute resource. At large scale, you know, you have 500 proxies to go with 500 microservices, in addition to all the other stuff that's running in the Kubernetes cluster as well. So while it's not a huge compute sink, it is a sink, right? So that is another way to do this. It does require those additional steps, and it does require a certain amount of resource in order to do this. So now we go to the third one, which is the one we're going to talk about today. And the main benefit of doing policy at the ingress level is that it becomes a very, very easy dividing line between what the application developer or microservice developer is responsible for and what the policy administrator, whether that be operators or sysadmins or whoever it is, might be the security people, depending on how big your company is, it separates them. And it puts a very distinct line there. It also brings in a couple of other benefits, and these is where Traefik shines. The first thing is that if I put policy separate from the deployment into the cluster, it means that I can change the policy as needed instantaneously without ever having to change the Kubernetes pods, deployments, daemon sets, the Kubernetes services, and the ingress routers that have been created to bring in that URI into Traefik. I don't have to change any of that to change the policy, right? So the developer writes his microservice independent of policy. The Kubernetes cluster is configured and the service and ingress router are deployed independent of policy. The policy is done completely separately. So changes to it become instantaneous. There's no downtime, right? Because if the policy changes, nothing happens in the cluster. The policy just changes, okay? And I'm going to show you what that looks like. And once it's done, once the ingress routers are configured, you never really have to touch them again. The only time you would have to do that is potentially when you change the URI path of that microservice in your whole web application. So that gives you an enormous amount of power, right? The second thing is that it means that the policy agent, where this policy resides, now can be managed independently, right? So if you need to shut something off really quick, rather than killing the pods, you change the policy to deny access. So you can do a lot of things very, very quickly. And you're going to see I can make changes to the policy and have them interact with the service instantaneously without any worry that I'm bringing down a service or a part of the cluster or anything like that. Okay. So what does this look like? So I'm going to show you a picture and I'm going to demonstrate how I built this. And like I said, all of the code is available, so you'll be able to get to it. So at the Traefik level, what we did was we set up the ingress routers for each of our microservices to be almost exactly the same. Right? The only thing that's different between the services is the stripped prefix. And the reason that's there is because our microservice that I'm using to demonstrate with actually needs the root URI. So that's a very common thing. The second thing is that the policy middleware is implemented using Traefik's standard forward auth. Now, forward auth allows you to send off all of the information Traefik knows about the request, and whatever that forward auth forwards to has to come back with a yes or a no answer. And it does that by saying 200, the HTTP status code 200, or unauthorized. Now, that's fine, but that means that whatever you're forwarding to has to do all of the policy work. So what I did was I built a very small little server, and that's exactly what it does. The small server I built, which is in the code, is basically the endpoint for forward auth, and it calls out and checks the policy. The huge benefit here is that we're using standard Traefik middlewares. There's nothing special, no code that you need other than what I'm providing. The little shim server that goes between the policy agent and Traefik runs in a container, right? It's teeny. It's a I don't know, 100 lines of Python, not even. And obviously you can change it and alter it and make it do more than I did, but I did a very simple case. I said, take the request that's coming from the ingress router, send it off, have it, the policy checked based on the headers that Traefik provides, and then give a yes or no answer, right? The policy agent I'm using is OPA, Open Policy Agent. Open source project, very widely used, super fast, very reliable. I'm doing it as a server. You could also embed it into my little shim server if you just wanted to use the libraries. So you can do it either way. So what I designed very simply was this architecture, something very simple. So we have 3 microservices. We have the red one, the green one, and the blue one. They are connected via an ingress router object, which we're going to show you in a second. And the ingress router object has 2 middlewares. It actually has 2 middlewares that each one of them checks against. One of them, as I said, is strip prefix, and the other one is forward auth. And then obviously we have the Traefik ingress controller. That's a pretty good example of what we're looking at. And I'm going to stop for a second and just see if there's anything specific. Nope, nothing in the chat. So we'll just keep on going right to the demonstration part. Okay, so I'm going to switch screens. Give me 1 second. And please tell me if anybody has trouble reading this. So first thing, we'll move that off for a second. I assume if you can't see my terminal, please ping us and let us know. Okay, it's kind of hard because I can't see it remotely. Okay, so let's start with the basic parts. What did we do to Traefik to make this work? I'm sorry, let's go to the microservices. I'm actually looking at the code that is available on GitHub, so you can go back and look at this. So we have this microservice called PodInfo. PodInfo is a very simple service. It allows us to do some fairly straightforward things. Specifically, it allows me to create it so that I can tell which microservice I'm going to. So to give you an idea, as I said, we created the red, the blue, and the green service. So let me just show you what one of those looks like. So let me just jump over to the browser real quick. And we'll put in this URL. And so you can see this is the green microservice, okay? I deployed 3 of them. So in the deployment YAML, just to give you a quick idea, you'll see that there's the red server, the blue server, and the green server. So each of these is the same microservice. The only difference between them is I changed the background colors so that we could pick them out. Now, more important is the middlewares. So, by the way, I did deploy a service for each one of them. So there is a red Kubernetes service, a green Kubernetes service, and a blue Kubernetes service. So let's talk about how we did the middlewares. So the first middleware that I created was a forward auth middleware that, and this is what talks to that little server that's in between that goes from forward auth out to the open policy agent. All right. The good thing here is that I can use the same one over and over and over again, because this middleware is going to look the same no matter where you run it. It could be it can be common across all the namespaces, as you typically aren't going to run more than one policy server. So this one's fairly straightforward, right? And then for each of my microservices, I have a strip prefix middleware, which basically just takes off the beginning of it. And so there's one for each. Now, in order for me to use both of them, I went ahead and chained them together. So this is a Traefik 2.0 thing that allows you to chain multiple middlewares in a specific order. So you can see I strip the prefix and I do my forward auth, and there's one for each of the microservices. These definitions, these declarations do not ever change. They stay the same no matter what. So from building up the cluster and building out the infrastructure and the routing patterns, it means that, hey, this is pretty straightforward. I can actually leave this alone. It never now has to change. To me, that is a huge benefit, because it takes me away from the realm of having to worry about making code changes or making redeployment and potentially not having my cluster up and running. So this is the dashboard for this cluster. Right, we'll just jump in real quick. You can see here's my services down here. There's 3 of them. They're the URIs. One is foo, one is bar, and one is foo bar. All right. When you take a look at the services, you can see basically they're laid out fairly straightforward. And when you take a look at the middlewares, you'll see that there's a chain and a strip prefix for each one. Okay, so that's how this gets done. So each of the services, when I pick one of the ones that I'm working with, right, it lays out very quickly. And when you look at the router, the actual ingress router for any one of them, you can see the middleware chain here, and here's the chain. So for each of the URI routes that I built, there is a strip prefix and there is a policy middleware, right? And that generates this web page. Okay, so barring that, I'm going to stop for a second and let me just check the chat window, see if anybody's, nope. Okay, we're just going to keep going. Now, the open policy agent as a container looks pretty straightforward. So if we just go out and look at our cluster, you're going to see the open policy agent here, and you're going to see my little shim server here. Right, very straightforward. Just below that, you can see my web application with my red and my green and my blue. You'll see at the very top, we did the default Traefik Helm chart installation on this cluster. Nothing special. This is out of the box, right? In the repo and in there, there's one value that we do change, and I'll talk about that toward the end. Right, so you get a general idea of how this works. Okay, now we're going to switch gears a little bit. So let's go over and take a look at what policy looks like. So the policy server runs as a container. It is a standard deployment, right? It can be deployed directly. It can be deployed any number of different ways, but there's nothing really special about it. It has a single container, right? You do use a volume mount just to store the policies temporarily for the duration of this policy agent running. And as you can see, if you make that persistent volume persistent, if the container goes away and comes back, all the policies you've put in will still be there. So this is a very simple thing. I have the URLs for Open Policy Agent at the end of the talk as well. Now, the small shim server, again, single container, does nothing very special. I actually publish this out into Docker Hub so you can go get this particular one. But there's a couple of things in here that I want to make you aware of, and we'll talk about what this does when we talk about actual policy. So the Open Policy Agent has the ability to have multiple policies. This one is called example. And I'll show you, I have this note at the end. There can be multiple URIs. So you could have multiples of these shim servers running, or you could take my shim server, which is very basic, and make it so it's more dynamic so that you could give it a path, let's say in the environment, perhaps from the ingress object or the ingress router object, or change it so that the environment gets set on forward auth. There's a lot of ways to do this. I took the simplest path, which was I'm using only a single policy, or set of policies, I should say. All right, still, okay, so now let's take a look at what a policy looks like. So we applied some policy. So what does policy actually look like? Oops, sorry. It's pretty simple. I'm going to move this up to the middle of the screen. So a policy basically has a set of rules, and we set some defaults. So in our secure world, I want to make sure that if there is no policy, the request is denied. So I set a default that says, don't allow. Now, the default answer is false. Do not allow it. In my shim server, I check for allow. And if it is false, I return an unauthorized code. If it returns true, I return an HTTP status 200. That's as simple as it can get. Now, one huge benefit, and I've got to flip it, well, I'll show it to you later. The shim server gets all of the headers that Traefik has. So there's a lot, and there's a lot of good information in those headers. So let's take a quick look, and I'll show you what they look like. The best part about this is that the policy can be set on any one of the headers, or any combination of headers, or authorization headers, or token headers from JWT. It'll actually decode them, so you can actually do some fairly sophisticated things. So let me just pull up the logs of the server, the actual OPA server. I turned on debug because I want to be able to show you what these look like. And yeah, I'm going to let it spin by real quick. Okay. So what can you make decisions on? I can make decisions on all of this. And if you look at that list, that is all of the headers that are passed in the ingress router object that is created. This is what Traefik gives me. Now you'll notice there's a lot of stuff in here that you could do. Traefik does some very nice things for us. Real IP is one of them, where it came from, the base URL that it was forwarded with, and the one that is after the strip prefix. So this is the one that appears after strip prefix. This is the one that appears before strip prefix. So you have a lot of options. Very important ones you're going to see here that I use a lot. The method, right? I want everybody to get, but I don't want them to post. Okay? Real IP address, the actual client IP that generated the request. And obviously any other cookies, anything else that is in the headers of the request, you can get to. The most common example is authentication headers, whether they be HTTP basic auth and digest, which you can do with a standard middleware, okay? So you can actually do the authentication, but you also may want to apply policy based on who the person is. That goes beyond just him being authenticated, right? The same would be true with using OICD or JWT tokens. So you could say my application is authenticated with Google Auth. So I am going to get the Google authentication in the headers, and I will be able to decode those and say, oh, he is in this domain, or he's in this group, or he's on this short list of people. And I can authorize or, allow or deny access authorization to see this particular URI. So that's what you can get to. So when you look at a policy, we go back and we say, okay, so the first one, the most basic policy is I'm going to allow any get request, right? That's pretty easy, pretty boring actually, but it is pretty easy. All right, so let's take a look at another policy. So we want to refine this. Well, yeah, what happens when I need to say, I need posts? He has to post too. So we change the policy. Okay, and all we did was we changed this one check right here to say, allow posts as well. Okay. Thing about policies, the way this works is everything inside that allow bracket is anded together. And in later examples, I'll show you what those look like. The policy passes if any one of the allows that is in this policy document is true. So you have to be a little careful, and I'll explain why. So in our website, we have 3 microservices, right? And the 3 microservices are, we have the foo microservice, which is the green server. We have the bar microservice, which is the blue one. And then we have /foo/bar, which is the red one. Oh, if I can type. Typing would be good. Okay. Now, as you can see, these are 3 separate microservices, but the URI path for one of them happens to be just an extension of the first one. So /foo is one microservice, /foo/bar is a different one. Now, how do you put policy against foo to allow one and not the other? Or potentially allow one to be a get and the other one to be a post? Or allow one to be everybody can see it, and the second one, only a certain group of people can see it. So this is where policy gets very complex when you had to tell a developer how to implement this in code. That becomes problematic. Or you have to implement it when you're doing the doing a proxy mechanism. But these policies can get very complicated very quick. For example, this URI /foo/bar, I only want the developers to see only if they come from this network and only if they've authenticated with their Google Auth and they're in this list of users. So that kind of policy is what Open Policy Agent does really, really well. Okay, so I've installed Open Policy Agent just so that we can do our experiments. I have port forwarded it back so that I can play with it, just to let you know. So you can actually test policy here as well. In addition, OPA has this nice tool called Playground that allows you to actually write and test policies before you implement them. So let's take a look at what this is going to look like. So the first policy we're going to apply, hopefully I've got an example of what that URI looks like. It is in here as well. So it's basically a curl. So to apply a policy on the fly without having to do any changes to anything else is merely a matter of a put. So I'm going to change it to policy 2, right, which now is going to allow me to do posts. Done. It's that simple. If I need to change it back, it's that simple. So what does that look like when it fails? Let me find an example of one that we did for a test. I'm pretty sure this one will work. Okay, this is a post request. Access denied. Policy does not allow access. Let's put in our post and let's do the exact same one again. And all of a sudden it works. The ability for me to do this dynamically and to do this programmatically, right? Because I'm using a URI and putting a standard policy document from OPA. I am just putting it there. Now you'll also notice that this URI here, that's how it matches them up. So the URI that my shim server accesses to test policy, right, if we go back and look, is the same. In addition, inside the policy document itself, you can have different URIs represented. That's what this does. And we'll talk about this. I have a couple of notes at the end. So that's kind of a boring set of things. So let's take a look at a different one. So when I said that you could have multiple policies, okay, now we really want to restrict something very, very specifically, okay? So if we look at these three, you're going to see that the first one says, if the URI path is /foo/bar, we're going to allow post. Otherwise, we're only going to allow gets on the other two. So the second allow section, if you look at that, says foo. And if I just said any foo, that would be everything, including the URIs below it. And I don't want that to do that. So I've restricted how it views the policy. It has to be only foo. Same here, it has to be only bar. And up here, it has to be exactly this. The first two elements of that URI have to be this. So let's implement this policy real quick, and we'll go back and use our post example again. All right, so the policy's in. And we're going to go and change. Let me just change this URL. All right, so this, I'm going to try and post to /foo. And if my policy that I set up here is correct, that should fail. Right, once again, I'm doing this right? But if I change this and say, well, does this work? Well, yes, we allow posts there. Same would be true for this one if it was bar. So you can see all of a sudden very quickly how easily you can build policy, number one, and secondly, how you can implement it with Traefik in almost no time. Right? They can be as arbitrarily complex as you wish. Right? This one I just said, okay, let me allow posting to this URI. Okay, so let's just implement that and make sure that that works. Again, can be done programmatically, can be done any way I want. So I'm going to stop for a second, and now I see questions. Okay, good. I see a couple of really good ones. All right, so we'll talk about how you approach some of the more complex problems. Most people who look at this are like, wow, yeah, that's very simplistic, and blah, 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 blah. And the answer is, yeah, it is. So let me switch back to the slides for a second, because there's a couple of points I want to make, and then we'll answer some questions. So let me get back to that one for a second, and I'm going to move that out. Okay, so a couple of notes. When you look at an input header, the actual transaction, you are going to get everything in here. Okay. Now, the answer to Alvaro's question, he's asking about CORS headers and things like that, right? Well, the thing that will become very apparent is the request. The request comes in with the request with a CORS header. You can turn around and set policy that says, if it's from this domain or that domain, right? Because I have it in the header. Right? So I can tell where it came from, and I'm also going to have the origin request as well. And I'm going to say if it's allowed from here to allow it through. So yes, you can build open OPA policy to do that very simply. JWT was the other thing he asked up. For those who don't know, JWT is a Java Web Token. And it is a token that is set up so that when you see it, you can verify it, number one, and number two, you can assume that the claims that are made in the data of the token have been authenticated. So for example, a username or an email address, very common thing. So Google, like Google Auth, right? When you say allow this application to use my information, basically what you're doing is you're saying this application has access to this information, okay? Or you grant access to your profile. You do this with GitHub, you do this with Google all the time. Very, very common thing. Those tokens are passed through headers in web requests. So you can actually build this out very, very simply. And to answer the question, OPA actually has a decoder library. So the Open Policy Agent has the ability to decode the actual token and get all of the data points out of it, which is really nice because then you can have policy says, if username equals this and email domain is this, and he's a member of this group, he's allowed to see this policy. So if you have authentication built in or using an external authenticator like Google or GitHub or Facebook or Twitter has one, I mean, everybody's got one, okay? If you are using those for your authentication with your applications, you can extract out as part of your policy some of the things that are in there that are contained in there and use those to make policy decisions. Now, if we go back and look at Traefik for a second, and we go back to our diagram, you begin to see that because the microservices, red, blue, and green, the ingress routers that control them never changed, right? And I can alter the policy based on new requirements without having to alter the code of the microservice or the deployment information that I needed with the ingress router for Traefik. It means that now the cluster can sit by itself and it can just run and it will run forever. right? Now I can implement what I need outside of that, independent of it, and the policy can be dictated by any number of things. So adding a authenticator screen to this, to your web application, is a matter of putting in a service where he logs in and it goes off and does the authentication, and it comes back with the tokens, and those tokens are decodable as policy. So I'll say, Alvaro, if put something in the chat if that answered your question. Okay, so a couple of notes, a couple of things that I came across that you want to look at how to do. The first one is to get that real IP address. Set the external traffic policy to local. By default, when you use the Helm chart with traffic, the value is set to cluster, which means the x-real-IP that appears in the header is the cluster IP address, i.e. the cluster of the IP address of the pod. Traefik has a very nice feature, which will allow you to get that from the outside world. So what the ingress controller sees as the IP address is what you will see. And that is a nice thing, because then if you need to do network restrictions, whether those be, internal network restrictions, let's say you're building an intranet or an application that runs internal to a company, and you don't want any external IP addresses to access anything, you can make that a denial policy up front and say, you have to be on the internal network always to get to see any of these things, okay? That is set in the values.yaml in the Helm chart. You're gonna have to pull down the values and actually upgrade Helm using Helm upgrade values file Traefik, and assuming you've already installed it. You could also just bring down the the values file and do it at installation time. That's a very common one, and pretty much all the ingress controllers that I've seen out there out of the box are not set that way. So definitely do that. But also keep in mind that depending on what CNI you're running on, whether it be cloud or on-premise, you may have to set the external traffic policy in the CNI as well. In this particular case for Amazon, where my cluster is running here, it creates an application load balancer, and you have to use annotations to tell the application load balancer to give me the real external IP address. MetalLB, others like that, also pretty much all the CNIs, Weave, Calico, that whole set, it all has to be set. So just make sure you do that. The other point I want to make is we talked about policy bundles and the idea of having more than one policy. So just as a notation, when you look at what's in the actual policy file where you define the policy, right? You saw it said package example. Well, if you go over to the URL that you use to access the policy server, they map one-to-one. Right, so it becomes really simple for you to be able to make sure that the policy files and the policy URLs, so you could have multiple URLs, multiple ingress routers pointing to different policies. In Open Policy Agent, they call them bundles. So you can bundle whole sets of them together. And that makes it very, very simple. It does mean that you have to be a little careful in your ingress router objects, as you saw, where you define that in the middleware. In my little cheesy example, you do that, you define that URL in the middleware that I created. You could make what I wrote, the little Python code, a lot more dynamic so that you could have it passed in environment variables, have it passed as the request URI. I mean, there's a lot of ways to do it. Right, so you might want to think about making my little policy shim server thing a little more robust. It's actually pretty fast. I was kind of scary how quickly you can do that. So So Patricia actually has a question too. Is it possible to do authorization for services in different namespaces using OPA and Traefik? Yes, absolutely. Is you can run one open policy agent and using different URIs. That's one way to do it. You could also use the namespace of where it's coming from as a way to identify the pod. There's a lot of information that is passed along in the headers that you can actually use to get to all of that. And really, OPA is a generic policy agent. It's not specific to one thing. It is super fast and it is very lightweight. I mean, it's teeny tiny. If you're worried about that, you can embed the library for the open policy agent actually in the shim server and have it just not even call over the network. But yes, that's an easy one to do. Namespaces don't matter. Remember that Traefik is dealing with the namespaces, and where you put the ingress route objects, okay, would be done that way. So I'm at a wrap point. I wanted just to touch on a couple of things. The example code of everything that I did here, all of the deployment for Traefik, including a values file for the Helm chart, is there. The example application I used, which is something called pod info. Pod info has a lot of nice options. The guy who wrote it works for Weave, and he uses it to test progressive delivery. That's why it has different colors. So you can watch a progressive delivery go from red to green or blue to green, or yeah, very straightforward stuff. Those deployments are in there, service deployments, ingress router deployments, as well as the open policy agent itself and the little shim server. The source code and Docker file for the shim server are in that repo as well. So you could take this whole thing and build this whole example set out and use for testing. At the very bottom also is open policy agent itself. So go take a look at the projects, pretty cool. They're very, very helpful if you have questions. They have good Slack and as well as community forum. And obviously for the Traefik community, you can use the Traefik community forum, which is also on this URL. And we just popped into the chat. Oh, one more question. How to audit if policies are not breaking? Oh, so yes, you can actually do that very simple. If I can get back to the log. So the open policy agent server actually audits every decision. Now you can turn this off, but it is available. I'm going to switch over to the screen for a second so you can see it. But basically, every query that goes through comes in and you can see the decision. So here is, I'm going to start at one right here. Here's the beginning of it. This is what the open policy server saw. All right, so it's going after this policy. And this is the information where it tells you about what the decision is. Right, and it is very, very, very specific. Right, so I can actually look at, here's the headers I received. Okay, here's the decision ID. And if you look at the decision log, you can see the path in was example. The fact that it's coming from the internal IP addresses because the shim server sent it, and you can see the result. But if you're really stuck, you can actually go and do something even more fun. I tend to use the open policy agent playground to test policy. So you put your policy over here on this side, you put some input data over here, and you watch for the output data down here. So I can just click evaluate. So for example, if I change this one just for fun, make it something that's right. So I can do this very quickly. And that's how I tend to check policy. The question, oh, another question. Am I using the OPA gateway? No, I am not. I'm using the OPA server itself directly, and I wrote a small little piece that acts as a gateway between Traefik standard forward auth middleware and the backend open policy agent server. So if you do this, you'll see, right, here is the actual open policy agent server. And here is my little piece of code, which is acting as a gateway between the Traefik middlewares and the actual open policy agent server. Okay, well, those are all good questions. And I really think that as a mechanism for doing stuff, putting policy in at this level means that you get really, really very fine-grained control. It's always audited, and if you want an even more accurate audit trail, you could ship those OPA decision logs off, right? Because it's a standard container, they can get picked up by something like FluentBit if you want those decisions to be tracked. There's a lot of tools to help you build policy and test policy, and that makes it very, very simple. This demonstration that I did here, you can run in Minikube. This whole thing will fit in Minikube, spin it up, and you can actually build tests and make sure that your policy works. Check it against your authentication servers very simply. I tend to like using, for complex operations, we're seeing our customers use JWT. So they are using OIDC, they're using tools like DEX in order to inject authentication tokens. They like DEX because they can do multiple services. So it can be Google and Facebook and LDAP and AD and a bunch of others. So that's another one to look at. So look for DEX IDP as an authentication mechanism. On that note, I'm going to turn it back to Patricia.
Hey, Paul, that was such a great presentation. You are so good at presenting. And I think everyone here agrees with me that it was wonderful. And thank you so much for all your amazing questions. Really, really cool. So what's going to happen now is we're going to create a video from this, post it to YouTube, post it to our website, and I will email it to all of you who have registered. And we'll see you on Twitter and see you in the community forum. And stay tuned for more sessions coming up. But Paul, we wish you well, and we wish all the attendees well too.
Thank you very much. This was a lot of fun.
Okay, cool. Thank you so much. Let's do it again. See you later.
Okay, have a good day, all.